Yeah, thank you very much for inviting me to this great event, continuously from the last year. And today, this year, I'd like to explain our vision of the 60 values and technologies. And okay, so this is values of 60 we are thinking. Maybe similar, similar to the many of them, yes. And yeah, we identified 5 values on top of the AI for network, AI everywhere, so should be used as we discussed so far. But on top of that, sustainability, efficiency, customer experience, network for AI, and connectivity everywhere. These are the very, very important values of the 6C, we think. And I'd like to explain all of them, but due to the limited time, I will explain only these 3 points. Yes, mainly the radio technologies aspects. First, efficiency. And yes, many of the speakers already explained. We need to have a very simplified system for the 60, streamlined system and application operations. And we can consider the variety of the technologies, focus areas, as I listed here. And not only the topics on the simplified design, but also the AI-driven AI technologies, and also many of the advanced radio access technologies we can consider that they are already discussed in the 3GPP. In this presentation, I'd like to explain the red part, new radio network topology, network digital twin, and the sub-terahertz aspect also. Yeah, spectrum, yeah, as we discussed, the spectrum topics are very, very important and interesting. And of course, even for the 60, we will continuously use the current existing spectrum band, which are already used in the 5G and the 4G, mainly the low band and the mid band. But many of the people has a strong interest in the higher mid band, yes, 6 to 8 gigahertz, yes. And also, the 5G millimeter wave has already allocated, and in Japan, we deployed the millimeter wave in the US. And we think, but as you know, the millimeter wave is not so deployed all over the world yet, even including the Korea. But for this 6G, maybe we should reconsider, we should have more interest in the use of the higher spectrum band, like a millimeter wave. And actually, a sub-terahertz, that will not be deployed in the day 1 of the 6G, but for the future, day 2 or day 3 of the 6G, maybe we should consider to deploy the sub-terahertz to boost the capacity and the data rate. And but we have many challenges in the sub-terahertz, so we need to address. We need to conduct some research experiments on the sub-terahertz technologies. And to deploy the variety of the spectrum band, like including the higher spectrum band, like a millimeter wave or sub-terahertz, maybe we should deploy the new way to deploy the systems, yes, such as a repeater and metamaterial technologies, metasurface lens, or and the distributed MIMO, repeater, device-to-device, RIS, also, of course, a very interesting topic. So for operator point of view, the utilization of these new technologies could be a good approach to expand the coverage, to improve the service area performance with the reasonable cost. But of course, it is very important to control these kind of the devices or the technologies. So we need to develop the new control schemes and operation schemes for the 6C, we believe. And so far, we addressed a variety of the technologies like this, and the repeater system, and the metasurface lens, RIS, and metasurface lens, and also analog radio over fiber is also very interesting, higher, especially for the higher spectrum band. Maybe we should use the analog radio over fiber technologies. And also distributed MIMO is also very interesting topic and to boost the capacity and to have a much better performance data rate. And we conducted many trials on the distributed MIMO, and that shows a very good gain to boost the stable and higher performance, higher data rate. And also digital twin. Digital twin is also very interesting topic for everybody, including the academia. And in order to develop our systems, and in order to decide our deployment of the systems, this digital twin approach is very good. We can find a very better approach, better deployment schemes with the shorter time and also lower cost. And especially the physical layer, in the physical areas, we can get a variety of the data using the variety of the sensor, and we can get the data from our base station and the terminals. Those kind of data should be detected and collected and submitted to the cyberspace and simulated, and then the results should be applied to the physical space immediately, so that we can improve our system very quickly and very well. And yeah, we have already using this kind of the digital twin approach, even for the 5G current system. Maybe not only DOCOMO, but also many of the operators using this kind of schemes already. But maybe towards 6G, we will use the digital twin more and more for not only for the layer 1 physical layer, but also a higher layer and the application layer, and also a core network and the whole system. We can do the simulation to improve the system. And yeah, last year event, I explained that this digital twin simulator using the point cloud data. And here we showed this kind of the simulation results. This is the real factory simulation result. Yeah, this is the Omron's factory. And we use the point cloud data, and we could do the simulation for the real factory environment. And we can set the base station antenna very flexibly, and we can set the users very flexibly, and we can conduct simulations. And easily we can get this kind of heat map, and we can have an actual data rate of each users very quickly and very easily. Yes, this is a very good approach to provide, to sell our system to the factory partner, factory users, how to set the antenna and what kind of the performance we can provide in the real factory environment to our partner factory companies. Yes, and this is the indoor factory case. But the factory is very big, and also inside the factory space, the factory, the height is very high, like this environment, or much higher, and very big machines are located. And so if so, we need to have 3D models. And we already applied this kind of 3D digital twin simulator, so that we can, yes, analyze the potential performance with the 3D models like this. And also, even in the outdoor, we can get point cloud data, and we can conduct a simulation like this. And this case, this is the outdoor and the measurement course, and we conducted some trials on the digital distributed MIMO. And this left bottom, this is the point cloud data, and this image can be used for our simulation. And we had this kind of the simulation results. I would like to skip the details, but centralized MIMO and the distributed MIMO performance differences are simulated like this, and the distributed MIMO effectiveness of the distributed MIMO can be provided using our simulators like this. So anyway, this kind of approach using the digital twin is very, very useful to have a good potential performance of the new deployment or new systems or new frequency band. Yes. And also from here, I'd like to explain our activities on the sub-terahertz. And yes, sub-terahertz will not be deployed from the day one, maybe, but that will be a very interesting topic from the research point of view. And potentially, yeah, that the sub-terahertz should be considered to deploy in the future, later stage of the 6E. And we are collaborating with Nokia, and the left-hand side, this is Nokia's array antenna of the sub-terahertz and 140 gigahertz band trial. And also right-hand side is our collaborative experimental activities together with the NTT, NEC, and Fujitsu. And we achieved a very good performance at the 100 gigahertz and outdoor performance, outdoor environment, and the 100-meter distance. And we could achieve the more than 100 gigabps. So potentially, we confirm that the sub-terahertz can provide a very good performance even in the outdoor with a very long distance. But of course, line of sight condition, yes. And but of course, sub-terahertz, the higher spectrum band has some disadvantage in terms of the propagation loss and the blockage loss. Left-hand side graph shows us blockage loss measurements. And as you can see, the higher spectrum band blockage loss appears very suddenly and also a very, very big loss we have. And but on the other hand, we can use the reflections similar to the millimeter wave. And how much we can use the reflections? We conducted some trials using the Nokia's array antenna. And the right-hand side shows our measurement conditions. This is the indoor measurement, and the room size is 6.5 meter and 30 meter space, rather big room. And also we tried to use a reflection on the smooth surface metal wall like that. And we measured, we set the TX antenna here, and also blue points measurement position of the receiver. And also we set some the human phantom as some to have a non-line of sight condition. Yes. And okay, this is the detailed specification. The spectrum bands is the center frequency is the 144.5 gigahertz, and the bandwidth is 5 gigahertz, very wide. And EIRB or something like this. And the results. And we conducted the trials first. This is the line of sight condition, no blockage. So yes, the TX beam is transmitted to this direction, and more than 10 gigabps achieved, very high. Yes, of course, line of sight condition, very good, sub-terahertz. But if we set human phantom here, so non-line of sight conditions, zero throughput. So blockage loss is very, very severe. Yes. But if we change the direction of the beam by the 45 degrees, like this direction, from here to here, this direction, and reflect it on this metal wall, and the performance achieved very high, close to the 10 gigabps or something, so almost close to the line of sight conditions. So this result shows the sub-terahertz, even in the sub-terahertz, reflections can be used very well. So that, yes, the blockage loss, propagation loss is high, very high, but especially in the indoor case, we can use the reflection very well. This result, this experiment shows that such kind of the usefulness of the use of the reflections even in the sub-terahertz. But of course, we need to conduct more trials to use the sub-terahertz in the real mobile communication environment. So, but this could be one of the good starting point to consider to use a sub-terahertz. Okay, so network for AI. Yeah, we had many discussions on AI, but also, yeah, we are seriously thinking on the AI, especially AI-centric network we are considering, and the both direction, AI for network and the network for AI, both direction need to be considered, of course. In my presentation, I'd like to explain some of our activities on AI for network. And this is slide show the portfolio of the AI for network. We think many of the technologies, many of the use cases can be considered for the AI for network, as you can see. RAN side and the core network operation and the maintenance side, and also immediacy and the efficiency point of view. We classified like this, many topics. And after this, I'd like to explain the radio spectrum efficiency improvement activities. This is our collaboration with the Nokia and the SK Telecom. Thank you very much, SK. And yes. We are addressing the AI interface, especially for the pilotless communications. And yeah, as you know, the pilot signal is some kind of overhead of our radio transmission. And AI can replace the pilot signal channel estimation, yeah, potentially. So this is developed by the Nokia, and we conducted a variety of the trials, indoor and outdoor. And oh, sorry. Especially with this AI approach, ML jointly optimize the transmission constellation and the transmission path estimation equalization and the demonstration in the receiving processing. So TX side, RX side, both, we applied AI technologies. And we conducted trials in this kind of indoor environment, and we measured the performance, the static measurement and the dynamic measurements. And results shows like this. Right-hand side, this is the static measurements. And actually, a static measurement performance is very good, and no broke error occurs. And then we can get that gain with the pilotless transmission. The pilot overhead is around 80%, 18%, so that the gain is, yes, equal to the pilot overhead, the 18.2% gain we can get, yes. And dynamic measurement case, the working speed dynamic measurements, we had some broke error. But even in the case that we had a broke error, the pilotless transmission, the reduced the overhead gain, it's outperformed to the broke error. So still we can have a gain around the 6 to 16%. Yes. So this result shows the AI interface, pilotless transmission utilizing the AI technology, working very well. Yes. So we are now conducting the more and more trials, not only the indoor case, but the outdoor case. So of course, we can try new algorithm, and we need to use the more new data. Yes. And then maybe we can improve the performance more. So this could be a first step of the AI interface, pilotless transmission. Okay. And finally, connectivity everywhere. Yeah. Yes, as many people mentioned, end-to-end, very interesting. And our point of view, we would like to use all of the solutions, Zio, Leo, and HAPS, and also, of course, TN. Integration, interwork. Of course, we should consider for all of the solutions, 4 layers solutions, using case-by-case manner. And especially, we are aggressively working on the HAPS. And in this year, beginning of this year, January, February, we conducted a trial in Kenya. Yes. And we successfully get good results. with a direct communication between the hubs and the real normal commercial smartphone. And we had around more than 4 megabps as a direct communication. Of course, this is the initial try, and we will improve the more better performance to have a better performance, but this could be a very good initial steps to have a potential performance of the hubs. Yes, of course, NTN, we already deployed NTN Leo services on the Zio services, and we will provide this kind of hub service also in the future, in near future. We don't need to wait for the 6E, but this can be used for the even in the 5G era. Yes. Okay, and also hubs use cases, not only the communication, the variety of the sensors can be implemented, installed, so that we can get a variety of the data that can be used for the disaster case or some kind of the detection of the CO2 level or other use cases we can consider. So maybe we can have a more business chance using this kind of the data, yes, for the future. Okay, that's my presentation. Thank you very much for your attention.